Hello, my name's Christopher Collison, and today I'm going to talk to you about how to use Excel, and we're going to work through an experiment associated with calibrating a burette. And in so doing, we will understand how to take a look at data, how to use an average, how to use some standard deviation, and you're going to use this a lot during the rest of the course. So what is a burette? Well, a burette is used for measuring a volume of dispensed liquid. The burette, by the way, is shown on the left-hand side of the slide, and the burette is currently demonstrated to show some liquid being dispensed into an Erlenmeyer flask. So we consider that liquid that's dispensed to be an aliquot. This is useful for titrations. You'll come to do a lot of titrations in future classes in your RIT chemistry career. But we're going to be thinking about how we calibrate this burette. So why would we need to calibrate the burette? Of course, no piece of glassware is perfect. There are always some tolerances in manufacturing. And so the printing of the lines on the side of the burette and the quality of the glassware are not 100% perfect. We might say, well, what is perfect? We can think about that at a later time. But for now, let's just recognize that we want to know exactly how much volume is delivered against what is measured to be delivered on the burette. So how, in other words, do we know that the scale is correct, and how can we calibrate the scale on that burette? And what systematic errors are there on the side of that burette? And this is what we're going to think about when we go through and start to look at the functionality of a particular spreadsheet program called Microsoft Excel. So here is a spreadsheet in Microsoft Excel of the data that has been collected in a particular experiment to calibrate a burette. What you'll notice is that the spreadsheet is laid out into columns, and the columns are given letters, and there are rows on the left-hand side here, and the rows are given as numbers. We can click on an individual column and highlight that column. We can also click on a particular row and highlight that row. The data that we're going to be looking at is provided with the amount dispensed given in column A in here, and we're told that we're dispensing 10 milliliters, and there are 3 trials given. We'll come back to the number of measurements here and how we'll calculate the mean or the average of those trials in the future. So it's good practice to label the columns that we're working through. What we're going to imagine is that we're going to measure the mass of the water that's been dispensed, as well as the mass of the container into which that water is dispensed. So of course we'd have to know the mass of the empty container before we dispense the water into it. And so what we can recognize here is that the water plus the container is about 48 grams. Notice also that when we are trying to calibrate the burette for larger volumes, for example 20 milliliters or 30 milliliters or 40 milliliters, we're also making separate measurements of a dry container into which we're depositing some of that water from the burette. So in this case, you'll recognize that the mass of the empty container is 38.4859 grams. If we're depositing 20 milliliters into that container, we would expect, given the density of water being about 1 gram per milliliter, we'd expect that mass to go up by about 20 grams. So in fact, there are 15 separate measurements that are being carried out, and we recognize here the importance of multiple measurements to test for reproducibility, multiple measurements to enable us to do some statistical processes, multiple measurements that allow us to get closer to the truth when it comes to a good calibration of the burette. We'll come back to the density of water later. We can enter that number based on a recognition of the water temperature. We note that as the water temperature increases, the density of the water will change. So we're going to look up that number later. We can actually use a website to help us find those values. But what we're now going to do in Excel is demonstrate the speed of doing calculations throughout a particular column. If we, for example, want to calculate the mass of the water, well, this would be a straightforward subtraction. We're going to subtract the value in column C in here. So this is the mass of the water plus the container. And we're going to subtract the mass of the empty container. And we would do this in Excel by simply typing in the equation that we'd want to enable in that particular cell. So the cell is highlighted in green here. And what we're going to do is focus our attention on this top equation bar up here. And I'm just simply going to type in equals. And then I'm going to put the cell in column C, cell C8. And notice that Excel actually highlights that cell. It makes sure that we pick the appropriate cell. And I'm going to subtract from that cell number D8. Another thing I can do here is if I just click on D8, then that particular cell value, that cell reference, appears in my equation space at the top of the page. I press enter and I'll now end up with a calculation, and Excel does this automatically for me. And one of the other nice features of Excel is that I can actually drag and drop so that this same formula is carried out throughout the column. So in this case, what I might do is I might click on the little box on the bottom right hand corner, and I can drag that down through the column. That's one way of doing it, and you're going to see that that formula is actually filled in throughout. So if I click on a particular cell here, let's look on cell E15, and we go up to the equation in here, and we recognize that that is C15 now minus D15. It's carried through the equation throughout the column. Another approach to doing that, I can press Control Z and undo those changes. Another approach I can do is simply I can move down to the bottom of the cells that I'm interested in. If I have a really long column of data in here, what I can do is I can press Shift. I'm pressing Shift, and I'm going to click on the cell at the bottom of this group. And I'm also going to use an approach here which is called Fill. So I can fill down in here from the menu options. Another thing I can do is I can use a short key option, which would be Control D, and I'll show you the effect. I'm going to press Control D, and that fills down automatically. You'll also notice I'm going to want to delete these stray values in here because there are no data in these particular cells, because there are no trial values in these cells. So I'm just going to clean this up a little bit. Now I'm going to ask the question, well, how much volume was actually dispensed? On the day when these measurements were taken, the temperature in the lab was 23.0 degrees Celsius. So what we're going to do is we're going to look up that, we're going to go to this website, we're going to look up the value of the density of water on that day. And so here we are, we've come to the website. I can actually type in the temperature, 23.0, compressed degrees Celsius. I'm always going to be working in degrees Celsius. In a chemistry lab, I may occasionally be working in Kelvin, but let's calculate the density of water, and it's given to us here as 0.99753 grams per centimeter cubed. So let's transfer that over to our Excel spreadsheet. And so we have that density of water, and that's going to now allow us to calculate the volume that was dispensed. So the density is measured in units of grams per milliliter, and this can also help us figure out how to calculate the volume. So a volume is simply going to be equal to the mass divided by the density. In other words, we're taking a grams and we're dividing that unit of grams by grams per milliliter, and that will mean that the answer that we get will have the units of milliliters, which is what we want for our volume. So let's calculate in those terms. Let's take the density. We're going to use our equals function up here. So we're going to press equals. So that tells Excel that what we're placing in this particular cell is an equation. So equals, I'm going to take this mass in here, 10.0123, and we're going to divide that by the density that we've just found from our website. And we're going to press enter, and now we end up with our answer. And what we might think is, let's go ahead and let's try dragging down. Let's actually just drag down for the first 3 cells in here and see what we get. And what we're now going to find is we've got some errors that are taking place. We've actually got a divide by 0 term in here. So what's actually going on? Well, it turns out that what happens as we we drag down is we're actually taking our mass here. Okay, so if we highlight this particular cell in F9, what we can find is that we are indeed in the numerator taking 9.9366, but we're actually dividing now by the value in C4. Of course, that's a null value, and so that's where our divide by zero error comes in. So what we need to do is we have to lock the denominator. We have to recognize that for all of the calculations done in column F in here, what we need to do is we need to lock the denominator to be cell C3. How do we do that? I'll show you what we do. So in order to lock it as the third particular row in column C, we're going to put a $sign in here before the 3. And what that does, I'm going to now demonstrate again by dragging that equation down. And what we can do now is recognize if I click in cell F10, what we find is that E10 is in the numerator. That's exactly what we want. But the denominator in here is locked as being the third row in column C. So we've locked row number 3, and that means that we retain this value. And we can actually, another thing we can do is we can copy. So I'm going to press Control C is my short key for copy. I'm going to press Control V, which allows me to paste into this cell. And what happens now is actually I'm pasting the formula with C3 locked as my locked cell. Okay, so that remains in the denominator. I can again use the drag down function and drag through these cells. Again, before I used the short keys Control C and Control V for copy and paste. Another thing I can do is of course use the menu here, so I'll press the copy button as I'm referring to this value here in cell F13, so copy, and then I click in here and we will paste, and it gives me an option of whether to paste the formula. I'm going to paste the formula in this cell in here. We'll paste that formula. Okay, and there we go again. That formula has been transferred down, and again we can continue through with, we'll use the drag all the way down here, and I'll clean this up by removing the zeros. So that shows you how we can lock certain cells when we're doing a calculation. What we can also recognize here is how to use a function such as to find the average of a particular set of data. In this case, we're going to use the average function. And I'm going to go back, let's look at cell 11. What we're going to do is find the average of all the cells above it as we move from left to right across row 11. So let's introduce you to a function called average. And what happens is, as I start to type average in here, what happens is we get a list of options in here that Excel offers. So I can click on average here, and it even tells me what that function is. So the average, it returns the average, the arithmetic mean of its arguments, which can be numbers or names, arrays or references that contain numbers. So it returns the average of its arguments. So what that now means is I'm going to type in, or continue to type in, average, but it tells me what those arguments are. So I can type in all the numbers I want in here, but what in fact I'm going to do is I'm going to select these 3 cells. And if I select it by hand, by using the cursor, as I just did, what those arguments translate into in terms of the syntax in my equation in here is C8 colon C10. That's the starting and finishing cells in here. I've got to open brackets and close brackets around this. I press enter and my average value shows up. Another thing I can use here in Excel is I can again drag across in here. So there's my dragging across, and I've got the average of the arguments, that is the 3 cells above that mean value. So there was the average. Let's repeat down here again. Let's demonstrate how I did this. I'm going to press equals, type in average, Another thing I can do, I can type this in by hand. Okay, so that would be C13, cell C13. I'm going to type in the colon. I've got to recognize there must be a colon in here. I want the average to be calculated over cells C13 to C15. Okay, and press enter. Job done. And then I can drag across. Another thing I can do, if my argument range is the same, I can Control C, I can copy that value, and I can paste it Control V down into this cell here. And again, I'm going to use the fill right. Okay, there's a dragging approach in here. I'm going to try a different approach here. Control C, Control V. So I've now pasted my value in here. It's the mean. Another thing I can do, press Shift, click. It highlights all of these cells, and then I can do the fill right button, so I can press this fill right term in here, or it tells me already I can use Control R as a short key. Okay, so Control R, and again what I can do is actually in this case Control C. I can copy all of those cells and then paste them down here. What I want to do, of course, is always make sure that everything's been pasted appropriately. Whenever errors show up in Excel, you can bet that it's usually because something's been copied incorrectly or a cell has not been locked. So we're in pretty good shape right now. The final thing I want to show you again is the power of Excel, because at times we are often going to want to know the standard deviation. This is a way of quantifying the error of our measurements based on the reproducibility. So we have 3 trials in here, and we can calculate something called the standard deviation over all of those particular trials. So when and why do we use a standard deviation? When there is random error, so we can imagine that we are going to measure out 10 milliliters on 3 successive trials, there's going to be some human error which is only natural, and we have to find a way of quantifying this. So every time we think we're measuring out 10 milliliters, we're going to be very slightly off each time we do that. That is just a natural consequence of doing experimentation. We cannot be 100% accurate. But how do we account for that random error? Well, again, we can measure something called the standard deviation, and I will save the description of this for another presentation. But in this particular case, I want to show you how we use Excel to determine that standard deviation. And it's easy. We just press equals, and I'm going to start by typing ST. And what we'll find already is that a whole bunch of different options come up in front of us. Okay, so we want STDEV. I happen to know what that particular function is, STDEV. We're told here this function is available for compatibility with Excel 2007 and earlier. In fact, with newer versions of Microsoft Excel, the standard deviation functionality gets a little bit more powerful. So this calculates the standard deviation based on the entire population given as arguments. So I'm going to select STDEV.P, and then we're going to suggest the values, the arguments. So this would be the volume dispensed in here. So I'm going to select all those. Again, we'll note we'll use the colon in here. So we're going from F8 to F10, and that's going to be the standard deviation. That's a measure of the error, the random error for the measurement that we're making. So what we're saying here is the volume is dispensed is on average 10.0035 milliliters, and the standard deviation, so that would be plus or minus 0.0316 milliliters. So I'm going to go through and I'm going to again use the copy and paste function, and note that this works because I'm always got the same positions here relative to the calculation. If I really want to do this properly, I'm going to use equals STDEV. I can guarantee there won't be any mistakes in here, and I'm going to make sure I refer to the arguments that I care about and put in the closed brackets in here. And the last one I'm just going to copy and paste because I know that it works. So what have we done so far? We've used a locking approach to use a fill down when we have a single value. In this particular case, it was the density of water. I've also demonstrated to you how we can use certain functions in Excel. There are a ton of different functions. We can look those up. We just use simple mean, the average, if you will, and the standard deviation function. I will lastly just explain how instead of a mean function, you could go the long way around. We should be able to get the same value of 10.0035 if, of course, we sum up. So we'll use the sum function, SUM. This adds all the numbers in a range of cells. So we're going to sum these all up in here. And now we're going to divide by 3. That's the number of samples that we have. And again, we end up with exactly the same number as 10.0035. But again, Excel is there to be useful and to create certain shortcuts, and those shortcuts work well so long as we know what we're doing. So we can use the average function in lieu of the sum divided by n approach. Let's stop there, and then in the next section we'll talk about how to plot this and how to plot a calibration curve that will help us determine how well the Burette can be used in a particular titration experiment. Thanks for listening. See you in the next presentation.